All right, today we're going to look at binary numbers. We're going to look at three key items. First item, what are binary numbers? Second item, how to convert binary to decimal. And then the third item, how to convert decimal to a binary. So what are binary numbers? Well, the numbers we use every day are known as decimal or base 10 numbers. So here we have an example of 2,713. Each digit in this number has a weight and a power of 10. So here we have the example. And if we look at this example, we see we have 2,713. We have the 3. If we expand the 3, we see it is 3 times 10 to the 0, or 3 times 10 to the 1. The next digit is 1 times 10 to the 1, or 1 times 10, or the number 10. Moving to the next item, we have 7 times 10 to the 2, or it's going to be 7 times 100, for a final result of 700. Then the last digit we have is 2 times 10 to the 3, or 2 times 1,000, or 2,000. So if we look at this, we see that every digit is in the powers of tens. And if we go back to when we started learning math, we would know that this is the 1 spot, the 3, the 1 is in the 10 spot, the 7 is in the 100 spot, and then the 2 is in the 1,000 spot. So we're going to take this and we're going to expand that idea down to binary. And what binary is, it's a base 2 number where we have weights that are in the powers of 2. So here we're going to have a binary number that's 4 bits. So 4 bits means we have 4 digits. If we look at the weights of these digits, we are going to have, oh, that's too far down. You see we have 2 to the 0 as the first item, 2 to the 1, 2 to the 2, and 2 to the 3. Well, what are those powers of 2? Well, that's 1, 2, 4, and 8. So we can say in this 4-bit number, we have a 1 spot, a 2 spot, a 4 spot, and an 8 spot. So let's look at a larger number. Let's say we have 7-bit number. Well, our values now are 2 to the 0, which is 1, a weight of 2, a weight of 4, a weight of 8, a weight of 16, a weight of 32, and a weight of 64. How we can figure out the weights is we know that our first digit will always be a 1. The next weight is 2 times the previous. So 2 times 1 gives us a weight of 2. 2 times 2 gives us a weight of 4. 2 times 4 gives us a weight of 8. 2 times 8 gives us a weight of 16. 2 times 16 will give us a weight of 32. And 2 times 32 would give us the weight of 64. So now that we have an idea of what the weights are, let's figure out if I was to give you a binary number, what number that would be in decimal. All right, so let's look at this example I have right here. So we're going to start off with a 4-bit number. I'm going to give that 4-bit number the values of 0, 1, 1, 1. All right, we're going to write down the weights underneath. So the first weight is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Well, we know the weight is going to be 1, 2, 4, and 8. So what are we going to do with this 8, 4, 2, and 1? Well, any place where we have a digit of a 1, we're going to take that weight and we're going to add it up together. So we're going to add up the numbers with a value of 1 in the binary spot. So that would give us, I have a 1 on the 8, so that's 8, plus I have a 0, so I'm not going to use this 4, a 1, so that's a 2, a 1 with a 1, 8 plus 2 plus 1 will give us the value of 11. So we know that 1011 is 11 in decimal. All right, let's do one more example. In this example, we're going to have a 5-bit number. Number is 10110. Okay, so let's do the weights. The weights are 1, 2, 4, 8, and 16. Again, we're going to add up wherever we have a 1 and use that weight. So we're going to cross out that 8 because it's a 0. We're going to cross out the 1 because it's a 0. So I'm going to start adding up 16 plus 4 plus 2. We'll have the decimal of 22. So we can go from a binary number and figure out what the decimal value would be. Well, let's go in the opposite direction. Let's say I have a decimal number 17, and I want to know what is that 17 in binary. All right, there's two ways we can find this binary value. First method, we're going to use division by 2. Let's zoom out a little bit here, and let's see what we're going to do. Okay, so I'm going to start with the number in decimal. The number in decimal is 17. I'm going to take that 17, and what we're going to do is divide it by 2. Okay, when we divide it by 2, I'm going to look to find out what is our remainder. The remainder is going to be important to us. So 17 divided by 2 will give us 8. And with 8, we'll have a remainder of 1. All right, so I'm going to keep dividing by 2. So I'm going to take this 8 and divide it by 2. I have a value of 4 with no remainder. I'm going to take the 4 divided by 2. I'll have a 2, again, with no remainder. I'm going to take that 2 and divide it by 2. I'll have a result of 1 and no remainder. I'm going to take the 1 and divide it by 2. I have a value of 0 and a remainder of 1. Now the key item is going to be, I'm going to start from the bottom and use that as the most significant. So we're going to write in the reverse order. So we're going to write in reverse order. We'll have that the binary now is 1, 0, 0, 0, 1. In this example ended up being symmetrical, but let's look at a second example. Let's look at 25. So if I have 25, what value is that going to be? All right, so I start with 25, and divide it by 2. I'll have a result of 12 and a remainder of 1. I'll take the 12 divided by 2. I have a result of 6 and no remainder. Take the 6 divided by 2. Result of 3, no remainder. Take the 3 divided by 2. Result of 1, and I have a remainder of 1. Take that 1 divided by 2, I'll get to a 0 and a remainder of 1. A key item is you always need to get down to a result of 0. So again, we're going to take those numbers, read them in reverse. 1, 1, 0, 0, 1. That would be what is 25 in binary. Next thing we can do, a second method. Second method is, let's try to avoid all this arithmetic that we're doing and taking up room on the paper. So what we're going to do is try to find the value based off what is the largest number closest. So we're going to look at the 25, the one we just did. Okay, so we're going to look at 25. So I'm going to write out a number of bits. Let's say we do not know how many bits 25 is going to be. I'll write out weights. I'll write out a weight of 1, a weight of 2, 4, 8, 16, and 32. Once I get to that 32, I know 32 is larger than 25, that would get a value of 0. 16 would be the closest number that does not go over 25. So that we're going to get a value of 1. I'm going to find the difference. So I'm going to take that 25 and subtract 16 from it. I'll have a value of 9. Now what I'm going to look for is what number is the largest that holds up to 9. So I'm going to start from the 16th spot and look all the spaces to the left of it. So 8 is large and not larger than 9. So that would give a value of 1. Take 9 minus the 8, I get a 1. Again, I'm going to look to find the next largest. Well, 4 is larger than 1, 2 is larger than 1, and finally I have a 1 which is equal. And that's how I can find the number 25. So here are some you can try yourself. So why don't you pause the video right here, write these values down, and then I'll show the answer. So I have 2 for going from binary to decimal. The first problem is 11001110. The second problem is 1001001. And then I have 2 problems of going from decimal to binary. The third problem is find out what is the binary for 37, and for find the decimal. We have a decimal of 6, find out what the binary value is. So pause it, do the work, and then when you're finished solving, unpause the video. All right, so here are the answers. 1100110 end up being 102. 1001001 end up being 73. 37 is 100101, and 6 is 110. It is always fine to have extra leading zeros in binary digits. Well, I hope that was useful and that you know a little bit more about binary numbers.